So today we're going to cover Chapter 4, Section 3, and it's going to be on conics. And here are the different types of conics we're going to talk about in this chapter. In the previous book that we used to use when we were teaching this class, conics came later on in the book. So it's really nice that it's coming earlier in this book, because those of you who are juniors and who are going to be taking the SAT possibly in the spring, they tend to give a lot of conic questions. They tend to give circle questions. You're also going to get word problems based on parabolas. Classic problem would be like kicking a soccer ball in the air. And by using the shape of the parabola, think about the movement of the soccer ball. As it leaves the ground and it flies in the air, the highest point that that ball hits is the vertex of the parabola. And then you can find the height of how high the ball got by looking at the y value of your vertex. Then you can also look at the time that the ball spent in the air, and that's going to be your x value. So a lot of the word problems are based on parabolas. So this is good. I know we don't do a lot of word problems, but what you can do is, if you need to see examples, use your e-textbook, read through the applications, and look at some of those word problems. Again, you will see it on the SAT. Today what we're going to do is learn a few more parts of our conics, and especially we're just going to focus on the parabola today. We've already seen parabolas that have the U shape and the upside down U shape. Today we're also going to see parabolas that are going to take on a C shape and a backwards C shape. So let's first define what a parabola is. So here we go on this slide. Here is the definition of a parabola, and it is the set of all points, x, y, in a plane that are equidistant from a fixed line. And this is the new part. That fixed line is called a directrix, and then the vertex is also going to be equidistant from a fixed point, which is called the focus. This focus point is not on the graph or the line of our parabola. It's going to be actually on our axis of symmetry, or in this case, they call it the axis of the parabola. The midpoint between the focus and the directrix is going to be the vertex. The line, again, that's passing through that vertex, we know it as the axis of symmetry. The book calls it the axis of the parabola. So whenever you see the words axis of the parabola or axis of symmetry, they're talking about the same thing. So over here in the picture, we can see the vertex is the bottom of our graph here, the minimum or the lowest point. Notice the focus point, it's going to be located inside our parabola. The parabola will surround it. And then the directrix is going to be an equation. It's going to be a line that's like on the back side of the parabola. Again, just like before, especially like when you did your completing the square video, remember your axis of symmetry is this line that goes through the vertex. It's always, in this case, when it's a U or an upside down U, it'll be x equals. But when it's a C, it's going to be y equals. So these are our parts of our parabola graph now. We're going to learn how to calculate the value of P. And what P is P is going to be the distance between the blue and the red here, between the focus and the vertex. The P value is going to be the distance, and it's going to be the same as how the distance between the vertex and the directrix. So that's going to be the P value that we calculate. Let's see what the standard form of an equation of a vertex is. Now, these two equations here are the standard form when the vertex is at the origin, at 0, 0. And I'll zoom in if you guys can't see. So here is the standard form of the vertex. When our vertex is at the origin, 0, 0, it's going to be x squared equals 4py, and p cannot equal 0. And then it's also y squared equals 4px, and again, p cannot equal 0. The focus will lie on your axis of symmetry, and the p is going to be the distance. So again, p value is going to be the distance from the vertex to the focus and also the vertex to the directrix. The distance between both of these is always the same, and the value or the distance amount is always the p-value. Now I'm going to add in another slide, and I'm going to add you some more details to possibly help you understand how we're going to get this focus and this directrix point. Now, when you're doing the WebAssign homework over the weekend, it's going to ask you to find the focus point. It's going to ask you to find the equation for the directrix, and then it's going to ask you to find the graph. So you're not going to actually have to graph the parabolas by hand in this homework. It'll just be that part of the question will be multiple choice. So you're just matching the equation with its graph. Pretty good on this slide? Let me add another one. I'm going to add a page here. And I'm just going to elaborate what's on that slide. So let's first talk about the x squared equals 4py equation, and I'm going to show you what the graph of the parabola will look like. Now, we're used to seeing graphs for the parabolas as y equals x squared. So this is different. We're going to now have the x squared isolated, or the y squared isolated. That's going to be your first step when you're solving any of these or finding the focus or the directrix. Make sure your squared term is all by itself. And the graph of the x squared, what we're going to do is whenever this p-value, so when the p-value is positive, when it's a positive number, our graph is going to be a U-shape. And this is for the x squared graph. When the p-value is a negative number, then our graph will be the upside down U. And the way that we're going to find the p-value is we're going to set 4p equal to whatever number is in front of the non-squared term. And you're going to see this in a minute. To find the focus point, what we need to do is first find the value of p. Once we find that, then the focus point just becomes 0, p, whatever the p-value is. Because remember, when it's an x squared graph, your axis of symmetry is going to be the y-axis. So that's why this point, this focus point, is on the y-axis. My directrix point, or sorry, not point, my directrix equation is going to be the non-squared variable. So see how the y in the original thing here is the non-squared variable, and it's going to equal the opposite of what you find for p. So negative p. So if p originally is negative, then the number you're going to use in the directrix will be positive. Now we're going to do the other one, and that'll give us the graph that's a C shape. So when your y is the squared variable, and if your p-value is positive, then your graph, if it's a positive number, your graph looks like a C. If the p-value is a negative number, then it's a backwards C. This time, our axis of symmetry, or axis of the parabola, is going to be the x-axis. So our focus point is going to be p, 0, because it's on the x-axis. Our directrix equation is going to be x equals the opposite of p. And this x is the non-squared variable up here. That's how you can keep things straight. These two standard form of the equations are only for when your vertex is at 0, 0. And the way that you can tell that is there's not going to be anything added or subtracted to the x or the y variables. We're going to see it later on, and it's going to become our h and k. All right, so let's go ahead and we're going to graph these. We're going to find the focus, and we're going to find the directrix. So let's go ahead and let me show you the standard form. It's in this format, x squared equals 4py. Your first step is to make sure that your squared term is all by itself. And this one is already all by itself for me. So what I'm going to do now is I'm going to take the number in front of y, which represents 4p. So here 4p equals 8. I'm going to write that equation. So the number in front of the non-squared variable is what 4p equals. I need to find the value of p by solving this equation. I'm going to divide both sides by 4, and my p-value is 2. Remember, p is the distance between the vertex and the focus, and the distance between the vertex and the directrix. On the previous slide, I told you that the focus point, when it's the x squared graph, remember your focus point is 0, p. So here, it's going to be 0, 2. For the directrix, it's the opposite of p, and it's the non-squared variable, so it's going to be y equals -2. So as long as you remember, you're putting this number, notice you're putting it in the y spot, but then you're setting it equal to the opposite of p, but to the y variable. And that's always the non-squared one. Let's graph it now. Make my x-axis and my y-axis here. I'm going to graph my vertex. My vertex is located at 0, 0. My focus point is at the order pair 0, 2. I'm going to say it's right here. The red is the vertex. My directrix line is the line y equals -2. So that's your directrix, y equals -2. Notice the distance between here and here is the same. It's supposed to be 2. So I put markings here. So this is the p-value. It tells you how far away the red dot is from the blue dot and from the green line. My parabola will surround the focus point. And that is your graph. I don't care how fat or skinny you make your U when the vertex is at 0, 0. When we get to the questions where the vertex isn't at the origin, we're going to find the x and the y intercepts to find how skinny or fat it is. Okay, example 2, we're going to do the same thing. We're going to make sure our squared term is all by itself, and it is. So now this is of this form, y squared equals 4px. I need to find the value of p, so I'm setting 4p equal to -28. I'm going to divide both sides by 4, and p equals -7. So my p value is negative, and I've got a y squared, so this is going to be a backwards c. So because this is negative, and because my original equation has a y squared, I know this is the backwards c. Let's find the focus point. For the focus point, when your parabola has the y squared, we know that the focus point is going to be p comma 0, so it's negative 7 comma 0. The directrix is going to be the opposite of p, and it's the non-squared variable, so it's x equals positive 7. My vertex is at the origin, so let's graph it now. Y-axis, x-axis, vertex, focus point, negative 7 comma 0. The red is the vertex. My directrix line is x equals 7. So I could come way over here and say this is x equals 7 in black so it shows up. That's your directrix. And then remember your parabola surrounds the focus. So example 3, remember we want to get it in this form. We want the variable that's squared to be all by itself and then equal to 4py. So I need to get rid of that 4. So I'm going to divide both sides by 4 to isolate the x squared. X squared, and I'm going to not leave it as y over 4. I'm going to actually make it 1/4. Because remember, we need to find p. And remember, to find p, we're setting whatever numbers in front of the non-squared variable equal to 4p. So 4p equals 1/4. I'm dividing both sides by 4 to get p by itself. Now, if you're not sure, on how to do this, you're doing 1/4 divided by 4. You can make the 4 fraction, do a keep flip change, and it's really 1/16 after you keep flip change and divide. So p equals 1/16. Remember to find your focus point. The focus, when it's the x squared, is going to be 0 comma p, so 0 comma 1/16. For the directrix, it's the non-squared variable, so it's y equals opposite of p, so negative 1/16. Again, nothing's being added or subtracted to x or y, so this is how I know my vertex is at 0, 0. So let's graph it. Come over here to the side. So my vertex is here. My focus is at 0 comma 1/16. So let me just say it's like right here. I'm going to say my graph goes by 16ths. So this is 0 comma 1/16. Remember, the focus and the directrix are the same space away from the red dot. So let me just put my green line like the same space away, but below it. So that's the equation y equals negative 1/16. And then your parabola surrounds the focus. So for number 4, we want to get it in this form of y squared equals 4px. So I need to move the 8 by dividing both sides. This becomes 1/8 x. I need to find my p-value. So remember, 4p is in front of the non-squared variable. So 4p equals 1/8. Now, for those of you who don't like to do it the way I did it before, and if you realize you're dividing by 4, which is really multiplied by the reciprocal, you can do it this way. However you want to get p by itself, because these 4's cancel, and then now I'm left with 1 over 32. That's my p-value. Let me find my focus. Now my p-value is positive this time, and it's the y squared, so I know it's going to look like a c. So my focus point is going to be at p comma 0. So 1 over 32 comma 0. Again, the vertex is at 0, 0. My directrix is the equation of the line using the non-squared variable and the opposite of p. So x equals negative 1 over 32. Let's graph it. Vertex 1 over 32 comma 0. I could say it's right here. My directrix will be the same space away, so I could say it's like right here. X equals negative 1 over 32, and then take your parabola and surround. Now, if you want to see specifically how fat or skinny these parabolas are, you can plug in x values into the equation or y values to get ordered pairs that are on your parabola. And then use the line of symmetry to get more points. But I just want to see that you're understanding the direction on how it's facing, whether it's a U, a C, a backwards C, or an upside down U. These are all for when the vertex is at the origin. Next, we're going to see when the vertex is at a different order pair. And that different order pair is represented by the letters H and K. Just like we did when we completed the square. Everybody good on this slide? Okay. So now we're going to change our location of the vertex. Now our location is going to be the order pair HK, just like we did before. But the only difference is, notice in the formula, they've got, I'm going to zoom in so you can see it better. Notice they both have subtraction signs in there. So when we pull out our H and K, they're both opposite of what you would think. Remember, H is always with the X, and the K is always with the Y. So just be careful, because notice on this one, you see how it switched places? Just remember, your K value of your vertex, it comes from the Y, and the X comes with the H. The P is still the distance. It's still going to be the distance between the vertex and the focus, and the vertex and the directrix. Now, technically here, we could also use these for the vertex at 0, 0. So for example, if I took this one, and let's say my vertex is at 0, 0, if I do x minus 0 squared equals 4p y minus 0, notice when I simplify this, it turns into the other equation. So technically you could use this also when the vertex is at 0, 0. Just know that when you're taking a number and subtracting 0, it doesn't change the number. So that's the only difference. So whenever you see something added or subtracted to your x or your y's, then you know that the vertex isn't at the origin. Everybody good on this slide? Let's do 3 examples. So here's our first example. So this is the standard form. X minus h squared equals 4p y minus k. So let's go ahead. My squared term, that binomial that's squared, is all by itself. So I don't need to move anything around. So I'm going to go ahead and pull my vertex out first. Again, it's backwards of what you think. So my H value is here, and my K value is here. But really what went in over here for the K was negative, negative, and that's how it turned positive. So when I go to pull the vertex out, it's 3, negative 2. Again, backwards of what you think on both. Then we're going to find the 4p value, or take the 4p and set it equal to the 4. Because again, the number that's here in front is what you set equal to the 4p. I'm going to solve for p by dividing both sides by 4. And p is 1. Again, p is still the distance between the vertex and the focus, and the distance between the vertex and the directrix. Now we actually have to do a little bit of simple math here to find the focus point. It's no longer on an x or a y axis. It's always going to be shifted away from this vertex. So to find the focus, we're going to take our vertex, which is the 3, negative 2, and we're going to go up and we're going to look to see which variable is not squared, and the non-squared variable is the y. So for this problem, I'm going to be adding the p-value to the y. Actually, let me shift this negative 2 over. So I'm going to be adding it to the variable that wasn't squared of the vertex. So my focus point is the ordered pair 3, negative 1. My directrix, I'm still using the non-squared variable. So it's the y. And I'm going to do the opposite of p. So I'm going to do negative 2 minus 1. Because this is negative p, or opposite of p. So my directrix equation is y equals negative 3. So up here, this is h, this is k, and then you add plus p to the non-squared variable part of the vertex. So just so you know what you're adding p to, look up at the original, and whatever variable wasn't squared, that's where you're adding p. And for the directrix, you subtract the p. Now, because we want to see how fat or skinny this one is, I'm also going to find my y-intercept. So for this one, to find the y-intercept, just like always, we're setting x equal to 0. So I'm going to go back to the original. So 0 minus 3 squared equals 4 times y plus 2. I'm going to solve for y. So negative 3 squared. I'm going to distribute. I'm going to square the negative 3. I'm going to move the 8. Divide by 4. And y equals 1/4. So my y-intercept is 0, 1/4. So let's graph this now. Let me come over here to the side. I'll make a coordinate plane. I'm going to graph my vertex. So my vertex is at positive 3, negative 2. My focus point is at 3, negative 1. My directrix is the equation y equals negative 3. My y-intercept is 0 and then 1/4. So I can make my parabola shape. Now, if you recall back when we did this before, to graph our parabolas, we used the line of symmetry. So remember, your axis of symmetry here is the x of the vertex. So it's the equation x equals 3. So if I were to draw an axis of symmetry here, to get the right side of my parabola, I could count, notice this is 1, 2, 3 spaces away to get to this y-intercept. So I could go 3 spaces away over here, 1, 2, 3, and then put my other point here. And there's your parabola. So for these, we're going to need to find an additional point, but we can use the axis of symmetry, or the axis of the parabola, to find that other point. Let's try number 4. So for number 6, make sure that your squared binomial is by itself. It's not, so I need to divide both sides by -4. Now I have x squared plus 3, x plus 3 squared equals -1/4 times y minus 2. Let me go ahead and pull out my vertex. So again, backwards of what you think. So I need to get the h and the k. So -3, +2. I need to find my p-value. So I'm setting 4p equal to -1/4. We're dividing by 4, which is the same as multiply by 1/4. And I get p equals -1/16. To find the focus point, we're going to take the p-value. We're going to take our vertex as well. And we're going to be adding the p-value to the non-squared variable, which is y. So I'm going to add the p-value, which is adding -1/16. So if I come over here to the side, I'm really doing 32/16 minus 1/16 because it's plus negative. So I get 31/16. So my focus is at -3, 31/16. If I make it a mixed number, because I got to graph this, it's really 1 and 15/16. That's my focus point. For my directrix, again, it's an equation. It's the non-squared variable. I take the y of the vertex, and now I'm doing the opposite of p. So what I'm really doing here is adding 1/16. So my directrix is 2 and 1/16. Now let me find, now let's go ahead and put these on the graph. Because it's a x squared, again, it's still a u. So I'm going to find, actually let me find my y-intercept first. So for the y-intercept, again, we plug in x equals 0. So -4 times 0 plus 3 squared equals y minus 2. 0 plus 3 is 3. 3 squared is 9. 4 times, -4 times 9 is -36. And then I just need to add 2 to both sides to get y by itself. So -34 equals y. So my y-intercept is 0, -34. So let's graph all this now. X and y axis. I'm going to graph my vertex. My vertex was at the order pair -3, positive 2. My focus is at the order pair negative 3 and 1 and 15 over 16. So it's really close. And then the directrix would be 2 and 1/6, which is like right behind it. So this is y equals 2 and 1/6. The vertex was the order pair 3, negative 2. No, negative 3, positive 2. And then the focus is the order pair negative 3 and 1 and 15 over 16. Let me graph my y-intercept, which is way down here. I could say that this is 0, negative 34. So now I can make the left side, the right side of my parabola. Go from the vertex down here. And now I could use my axis of symmetry. And you can see that it's 3 spaces away, 1, 2, 3. So then I can come at the same level, but 3 over to get the right side. The left side, sorry, backwards. And there's your parabola. Question? Yes. When you're doing this, your first step is to isolate the square. So whether it's a binomial or if it's just a term, make sure it's isolated, that there's nothing being multiplied to it. And then from there you can find your vertex, p-value, focus, directrix, and then an intercept. All right, let's try one more example. Pretty good? Last example. So again, make sure that the squared binomial there is all by itself. It is. So now I can go ahead and pull out my vertex first. So my vertex, again, backwards of what you think, but be careful. Remember, the K is with the Y and the H is with the X. So it's backwards now, because this is going to be a C. So my vertex is located at 3, positive 2. I'm going to set 4p equal to 24, divide by 4, and p equals 6. To find my focus, again, I'm using the vertex, but this time my non-squared variable is the x. So I'm going to add p to the x of the vertex. So my focus is located at 9, 2. So I'm adding the p to the x. My directrix, again, the non-squared variable is the x. I'm taking that x from my vertex and taking the opposite of p and subtracting it here. So then my directrix is x equals negative 3. This time, because it's a C, I'm going to find my x-intercept. If it's a U, you find the y-intercept. X-intercept, I find that by setting y equal to 0. So 0 minus 2 squared equals 24 times x minus 3. I'm going to distribute. 24 times 3 gives me 72. I'm going to square the 2, the negative 2. I'm going to move the 72. I get 76 equals 24x. Divide by 24. And when I divide it, I get 3.16 repeating. So I'm going to round this and make it 3.2. So my x-intercept is at 3.2, 0. Now let's graph the parabola. So here's my x and my y-intercepts. I can graph the vertex. It's located at 1, 2, 3, 3, 2. I can graph the focus point, which is at 9, 2. So 4, 5, 6, 7, 8, 9. It's way over here. That's the focus. That's the vertex. My directrix is the equation x equals -3. And my x-intercept is the order pair 3.2. So it's like right here. So you can make your parabola surround it. You could use the axis of symmetry to get another point here that it's equal distance away. So 2, 4. So here, equally distant right here. And that's the graph of your parabola. And that's the end of 4.3's notes. You have the web assign assignment. Okay, so again, this is the x-intercept that's right here. Again, our focus point was the order pair 9, 2, which was right here. Our vertex, our directrix was the equation x equals -3. So again, you have a web assign assignment. There's 6 questions. You don't have to graph in web assign. You're just picking the multiple choice answer. So that is it. Have a great weekend.